Good morning and welcome to another day of class. Today we have a beautiful lesson planned just for you. Today we move into our next unit, which involves factoring. And today we're going to specifically look at a special type of factoring, which is the greatest common factor. Now, before we get started in that, it might need to be known what factoring means. Factoring simply means you're looking at numbers that can be multiplied together to get another number. For example, 3 and 4 are factors of 12 because 3 can be multiplied by 4 to get 12. So 3 and 4 are factors of 12. Now you already know there are other factors of 12 such as 1 and 2. Or -1, -2, -3, -4. These are all factors of 12. So when we think of factoring, we look at things that are multiplied together to get another expression. Now, as I said, today we're going to look at finding the greatest common factor. Now, in order to understand this in a clearer understanding or a clearer way, we're going to look at some old stuff, some stuff that we've previously done. For example, in our previous unit, you were asked to simplify this expression. And we did so using the distributive property. Notice we have a term, 7, multiplied by another factor, 2x plus 3. And we had to use the distributive property, which simply says if you have some stuff inside parentheses multiplied by some stuff outside the parentheses, you're going to multiply every term inside the parentheses by the stuff outside the parentheses. All right, to make a long story short, the number on the outside gets multiplied by each term on the inside. So when you multiply 7 times the expression 2x plus 3, look at what you get. You get 7 times 2x plus 7 times 3. Now many times students do this in their heads, and that's fine, but we're just going to write it out for now for argument purposes. So we get 7 times 2x, which gives us 14x. Then we have 7 times the 3, which gives us the 21. Here is our expression in expanded form. We started off in factored form, and we have put it in expanded form. Now, when we look at factoring, we're going to start here and work our way back up. So, let's see, can we factor using the greatest common factor? All right. Well, let's start with the one that we just finished. The one that we previously have done looked like this, 14x plus 21. Now, the first thing we want to do is look at the coefficients or the numbers that are in front of the letters. All right, the first term has a coefficient of 14. The second term has a coefficient of 21. So, what is the largest number that can divide into 14 and 21? What is the largest factor of 14 and 21? Now, just in case you don't know where to go, write out all the factors. Let's look at, we have 14 factors of 14. 1 and 14, 2 and 7. For the 21, we have factors 1, 21, 3, and 7. These are all of the positive factors for the 14 and the 21. Now I'm going to look at the ones that they have in common. Here are the common factors. Out of the ones that they have in common, notice they have a factor of 1 in common. They have a factor of 7 in common. Out of the ones that they have in common, 7 is the largest. So 7 would be the greatest common factor for 14 and 21. Now, stop for a minute. Notice, The 14 has an x with it. Does the 21 have an x with it? Okay, good. No, it does not. So therefore, we cannot put out an x. They do not have an x in common. We're just going to take out what they have in common. In this example, they have a 7 in common. So 7 is our greatest common factor. I'll just put it out front. Now, as I said, we're going to undistribute. You're going to do this distributive property backwards. So now, instead of multiplying, you're going to divide. Here's how it works. Take each term and divide it by the greatest common factor. The first term was 14x. Let's divide it by the greatest common factor. The second term was 21. Let's divide it by the greatest common factor. Now, let's simplify it. 14x divided by 7 leaves us with 2x. 21 divided by 7 leaves us with 3. Now, you can always check your work using the distributive property. 7 times 2x, that should give us a 14x. 7 times 3, that should give us the 21. Now, just like we did with the distributive property, this middle term, or this middle section here is normally what we do in our head, but I just wrote it out so we'll understand what we're doing. I tell you what, let's do another. Can we do another? Good. Here we are. We're going to do another. I want you to factor using the greatest common factor. All right, let's put some nice numbers together for you. All right, here we have an expression that reads 4x squared y cubed plus 8x to the fourth y to the second. All right, now this one adds a few other things with it, but we can handle it. We can handle it. First of all, what is the greatest common factor for 4 and 8? All right, good. 4 it is. Good. 4 is the largest number that can divide evenly into 4 and into the 8. Now, notice something else. In this expression, both of these have x terms. This one has x to the second, this one has x to the fourth. Now, the question is, how many x's do they have in common? How many factors of x do they have in common? Well, to help you see that, I'm going to write out how many this one has. I'm going to write out how many this one has. Let's see how many they have in common. They both have at least 1x. Ooh, they both have at least 2x. Notice, they only have in common 2 factors of x. So therefore, I'm going to write it as x times x, which is the same as x squared. We'll simplify it later. Now, let's also look at the y variables. Here we have 3 factors of y. Here we have 2 factors of y. I'm going to do what we did a few minutes ago. Here we have 3, 1, 2, 3. Here we have 2, 1, 2. Let's see how many they have in common. They have 2 factors of y in common. So our greatest common factor would be 4 times x times x times y times y. Or you can write it as 4x squared y squared. All right. So here's our greatest common factor. Now, to find the rest of it, we divide each of the terms by the greatest common factor. And I'm going to write it all out in factored form. So this is 4x squared y to the third, which is 4x, x, y, y, y. Notice there are 2 factors of x, there are 3 factors of the y. And let's divide it by the greatest common factor. Now later when you are doing these, you will not have to write out all of these steps, but I'm writing out all of the steps so you'll see what's going on. And later, if you see some patterns, you can use those. All right. Let's simplify all of this nice stuff. Here we have 4x times x, that's x squared, and we have y squared. All right. Now, something is going to happen here. Look, 4 divided by 4, that's 1. X divided by x, that's 1. X divided by x, that's 1. Y divided by y, that's 1. Y divided by y, that's y. Look at what's left. The only thing that's left is a y. All right. Let's go over here to this term. We have 8 divided by 4, which is 2. X divided by x, that's 1. X divided by x, that's 1. Y divided by y, that's 1. Y divided by y, that's 1. So we're left with not just a 2, but you also have 2 factors of x here. So that's x to the second. So the factored form is 4x squared y squared, GCF, and here's what's left, y plus 2x squared. Now we can check the validity of our answer by using the distributive property. 4x squared y squared times y should give us 4x squared y cubed. It does. 4x squared y squared times 2x squared should give us the 8x squared, x to the fourth, y to the second. All right. Well, you've listened to me long enough. I think you're ready to try some by yourself. Let's go and do it.